chemical composition, antimicrobial activity, isolation, and characterization of the ES strand of Amphiphilesta vagella. Amphiphilesta vagella is also commonly known as cabbage tree. This plant has been found to contain a lot of medicinal properties, especially across the continent, Africa. Down to Sierra Leone, Ghana, Nigeria, they have known this plant to be used in the treatment of scrotal elephantiasis, jaundice, hepatitis, ovarian problems, even used to induce labor. But insofar that it has these beautiful characteristics, it has not been scientifically proven as to whether this plant can really exhibit this property. That is why my work is aimed at determining the chemical composition. By chemical composition, we'll be able to check to know all the compounds that are present in the plant. The antimicrobial activity by us knowing whether it has the potency to inhibit microbial growth. Isolation. If it does have the ability to inhibit microbial growth, then we have to isolate to know the chemical compound that is responsible for the inhibition. Thereafter, characterization, which will help us to elucidate the structure of that particular isolate responsible for the inhibition of microbial growth. Sample collection and authentication. The sample was collected along Jonathan Bypass, taken to the University of Calabar Botany Department Herbarium Unit for identification and authentication. After thereafter, it was taken to University of Cross River State Postgraduate Lab, where it was dried, blended, and extracted using ultrasonic bath with two different solvents, a polar and a non-polar solvent. The polar solvent will be methanol, the non-polar solvent being petrolmethanol. Then it was thereby stored and used for further analysis. The first analysis therein was the gas chromatography mass spectrometry. Here we use this principle to determine the chemical composition. The sample was injected into the GCMS machine, which was moved through the carrier gas argon into a well-compact column, which gradually eluted with different retention time. Then we move on. That same extract, we use it to check the antimicrobial, which is antimicrobial analysis, to know whether the plant does have the ability to inhibit microbial growth. But for us to do that, we use the broad dilution method. In the broad dilution method, we have to dilute the stock serially and thereby inoculate the pathogenic microorganism. We use about 3 of them, Escherichia coli, Staphylococcus aureus, and Candida albicans. In the stock dilution, here is the stock. It is 10 ml, after the samples, the test tube contain 99 ml. So 1 ml of this, having homogenized, is moved to the next test tube, being homogenized, moved to the next, and so on to the end. The dilution factor being the sample, the volume transferred over the total volume of the sample. That which is transferred is 1, and the total volume of the test tube is 10. That's 1/10. Then that same, this one was still homogenized and moved over. Now this becomes another 1/10. But by getting this 1/10, 1/10, if we have to turn it according to indices, which is 10 raised to the -1, we say that when number with equal bases are multiplied, the powers are added. So this multiplied with another 10 will give us 10 raised to the -2, and that trend continues. Although there was a control, which is ciprofloxacin, which was also done in this principle, but I'm only showing us this so that we understand how that goes. Then at the end of the day, when that has been done, the pathogenic microorganisms were inoculated at then stored, incubate for 24 hours at 37 degrees Celsius. When that is done, we bring out all the test tube. The test tube that is turbid, that color that is turbid, that before it shows the minimum inhibitory concentration. It means that this is the lowest concentration that is required to inhibit the microbial growth, which means 10 raised to the -6, 10 raised to the -5, and these were unable to inhibit the microbial growth. But this 10 raised to the -3 was the lowest that was able to inhibit the microbial growth, and that trend continues. Now, after the antimicrobial ability, then we understood that the plant was able to inhibit microbial growth, especially that of the polar solvent, which is methanol, was more potent in terms of the inhibitory properties. Thereby, we have to move further to isolate only the extract of the polar solvent, which is methanol. By isolation, we have two principles which we use majorly, which is thin layer chromatography and column chromatography. Thin layer chromatography is said by organic chemists to be the eye of the chemist because it will be able to show us what we are doing and what it is. And it works through the capillary action principle, which means the upward movement of the solvent and the compounds therein. So as they move forward, they separate. Chromatography will separate it into its constituent areas. But then, in the course of us doing that, there is what we call the retention factor, which is of interest to us. The retention factor, let's say, it ranges from 0 to 1. If it is 0 here, after putting the extract and it is being examined, there is nothing shown. It means it doesn't move. It is at 0. Then, if in this other case, it all moves with the solvent front, means it is more polar. But what we understood generally about the thin layer chromatography is that the lower the retention factor, the more polar the compound is. And the farther away the retention factor, the less polar the compound is. So in our attempt, if you look at this, although it's not very bright, you see the different movement at various ratios. Now, the one which I attempted to isolate was that, which is water, ethyl acetate, ethanol, and methanol at a ratio of 2:2, which is equivalently 1:1:1. The distance between them was 6 here, which I have. So, having run this is what I did. So, my intention is to isolate either of these of interest. So, in the process of doing that, having understood what I have here, I have to go back to column chromatography because the same ratio used here in thin layer chromatography, when applied to your column, is expected that the fractions will be collected in that same ratio. Let's move to column. Now, in the column, in organic chemistry, we tend to begin with a big column. So this is my column in the lab. Having arranged everything, it goes downward as the solvent, the same mixture ratio that was used in the TLC is being added in the column. It will be going down and various fractions will be collected. And it is important that we collect little by little because in the course of collecting one sample, you wouldn't know from here, you can't see specifically another compound may get in. So we collect little by little. If you look on the background, you see a lot of them which I have collected. Now, having collected this one, I have to still take them back to TLC, which is thin layer chromatography, to see if I'm able to get a clean isolate. So, having done that, I went back. I'm struggling to get the isolate. In that particular one, which is this, if you check, here I have not colored it. So, it wasn't well defined. My intention was to try to isolate this. So in the course of doing that, I got one here. Then this one, I have one, and so on. But insofar that this is what I have, the question is, how certain are you, or am I, that these isolates are pure? There are certain visualizing agents which we use to check. First of all, we have iodine. Iodine will help us to bring out the brown compounds that are there as isolate. We have 50% H2SO4 with water. That one gives us the black isolate. While the blue and green isolate, we use 2% KMNO4. And finally, there are those that are luminescence that ignite in the presence of light. So those ones we must have to use a UV lamp. So even if I have just one isolate, just one clear enough, the certainty of it being pure is not known. Even when you have decided to use all these visualizing agents, for example, if I have used iodine and there are black isolate there that has to be used with 50% H2SO4, I will not see that. It could be there. And there are certain ones you may not even see anything at all, and that can be visualized using a UV. But the certainty of whatever we are doing must have to be ascertained using some spectroscopic method, like the GCMS, for example, use the IR, use the NMR. In the course of all of this, successfully we were able to isolate just one, which I proceeded with. Now, the one that was isolated, because there are various fractions, you do not know whether they are so pure or not, but we have to move further to check our nuclear magnetic resonance, the infrared. From there, you will know whether there is at least, in all the samples you have, if you have a clear isolate. But in what we did so far, the nuclear magnetic resonance was to give us the proton, the chemical environment of hydrogen there, and we'll be able to spot, to say, okay, by elucidation, we'll be able to interpret what we're doing. The infrared spectroscopy here is to give us the functional groups therein. If we have the functional groups and our chemical environment with the proton in it, we can be able to interpret whatever we have. In interpreting what we have, we can determine or be certain that we have a clear isolate or not. So, here, the next is the result. We have various results, that of the chemical composition. I have for the GCMS analysis of the methanol extract about 15 different compounds, which continue. There are 15. But that of the GCMS analysis of petroleum ether, I have less than 15. It was because of that chemistry, I understood that there were more compounds in the methanol extract. And the methanol extract was also more potent to that of petroleum ether. That is why I proceeded with the isolate by isolating that of methanol in continuation. Is this the first? So, go back. Okay, I want to start from the NMR. So, continue. In the NMR, here it shows that we have 3 peaks, so there are 3 chemical environments. Now, we have to begin to check. By understanding the principle of proton NMR, we'll be able to know what exactly is this first peak, and the second peak, and the third peak. We work collaboratively with our what they call it, IRO, FTIRO, because it gives us the functional group. If we have the knowledge of the functional group, we can correlate to begin to tell which one could be this and which one could be that. Let's move. Go again. Here we come. In that of the FTIRO, we have this peak, which is around 1.7. It shows that there is a carbonyl group CO present. And if you come down here, around this region, this is a benzene peak. This too shows the benzene peak. We know that there is a benzene in that structure. So first of all, we have a carbonyl. In the first NMRO, we have a benzene. We are beginning to, but once there is a carbon, it means there is a carbon attached to O. Then we move further within 1000 to 1003, we have a carbon-oxygen linkage, which means that there is a CO and there is a C attached to O, before whatever. So that is a framework of an acetate to begin with. Now, having seen this, our mind has to go back to what we have in the NMRO. We can now correlate from the NMRO if that is the case. Now, what would be this and what would be this? We know benzene, the chemical shape of benzene ranges between 6.5, unless when there is deshielding because of the presence of a negatively charged compound like oxygen or chlorine, it can move a little further. So, having seen that there is a benzene there, and this could be benzene, but it is here at 7 or here at 8 because of that deshielding principle, which may have shifted it a little bit. Then, I could understand about the O, which is there. Then what exactly is this peak? Now, I could understand from this peak that I have a methylene group, which is supposed to be around 2 point something. But for it to be around 5 point means that it is closely associated to a negative charge group. So that could be the reason why it moved down further. Let's move on. Now, okay. Move further. Okay, hold on. Now, from here, I could understand my NMR spectral interpretation from this point. That the CH2 is present, is the one around 5.5. But why is it having a long peak? Because when we do our splitting, the compound close to it, we have the N+1 formula, which means the compound close to E must have at least 5 hydrogen or more. So if it is 5 as taught by my calculation for the NMR plus the 1, 6, that peak will be very long. If it doesn't, if it is just having just one hydrogen atom, it will be very short. At least from there, we understand the basic principles of the NMR. But here, the CH2 is having an oxygen there. That is what they have pushed it to that 8. And this one, the reason why I attached it there, I do not intend to include it there, but to show that there is a linkage between this and this. Go down. This is for the I arrow, FD I arrow. That is the C double bond, which is at 1720, C oxygen at 13 to 100, and the benzene is at 16, which confirm that this functional group are already in the FI arrow, and this correlates with the NMR, having seen that there are 3 chemical environments. So I move further. Go down. Good. So having seen this, I came to, because the chemistry is, we have to combine them. Somehow, we must get a structure from what we have. So I look at this. The reason why this guy was so far off 5 is because it's having a hydrogen this side, which will give it its 5 hydrogen attached plus the 1, which is 6, which went up. But it also has oxygen here. That is a deshielding factor. That's why it moved that far. And this benzene, having this and oxygen close to it, that's why it moved to that 8. And yeah, and this other benzene ring with a carbon double bond O was B, the reason why it moved to that 7. From my elucidation, this is the structure I got. Move on. Now, the result for the minimum inhibitory concentration of the pathogenic microorganism. Here, remember I say I use petrolameter, I use methanol and ciprofloxacin. The ciprofloxacin is a control. We know that to be a drug, which we use in the treatment of typhoid and all of that. So we have to compare it with what we are doing. Does it also possess this tendency of inhibiting microbial growth as compared to this other two? So having seen the first one, petrolameter, for Staphylococcus aureus, it is at 10⁻², which means it is very low. Its ability to inhibit microbial growth is almost gone, so it's very small. But that of methanol is at 10⁻3. That of ciprofloxacin is 10⁻4, which means that of ciprofloxacin, in terms of inhibiting Staphylococcus aureus, was more potent in these 2 cases. But that of E. coli, we realize that this and this were the same, but that of methanol was more potent in that sense. And in the last one, Candida albicans, the 2 here are the same, while that of petrolameter is lower. That was the reason behind me abandoning petrolameter to move on with methanol, because from my observation, it was more potent to petrolameter, because I have a control ciprofloxacin, which I could see that. Conclusion. The aim of my work was to determine the antimicrobial activity of the plant and to cluster Bargella, because it has been shown that it has the ability to treat various diseases, and our job is to confirm if it is a fact that it has this potency of inhibiting microbial growth. And we have seen that. And also to isolate, which means I should have a compound to correlate to the chemistry that yes, truly, the isolate which I have has the potency of inhibiting microbial growth. And the isolate, the benzyl acetate, shows in its properties that it has the ability to treat certain diseases like scabies and all of that, which there is a truism in that reality. And the chemical composition, though there are a whole lot of them, I was able to see them, and that of methanol was higher. And finally, for the characterization, which is IR and NMR, they were truly a factor in elucidating the structure which I intended to get. So from all of these things, our objective of getting into this work was achieved. That the plant Antoclesta Bargella truly possesses the potency of inhibiting microbial growth. That could be the reason why it is a known tree across the continent, Africa, and we have confirmed that reason. Thank you for listening. Thank you.
Yes, sir. Thank you.